By first, thanks to Biswanet and everybody at the organization and scientific committee of the conference for inviting me to give this talk. Are you seeing the screen? Is it shared?
Yes, sir. We can see the screen.
Perfect. Okay, so yeah, I've been already introduced, so I will start directly with the talk also because I see it's past noon. So this talk is about VocBench 3, which is a system. Sorry? Sorry, Biswan?
Yes, sir. Go ahead with the talk. Go ahead with the talk.
So I said this is a talk about VocBench 3, which is a platform that has been developed within the European Commission and specifically by my development team for developing ontologies, thesauri, and lexicon. Thank you, Biswanet, for the introduction to Semantic Web, because this will be very useful for understanding better the content that will follow. So one thing, I prepared many more slides than what is needed today, but I think that since the slides will be downloadable after the talk, it is good to leave you some more material for understanding the platform and for familiarizing with it. So the four main points of the presentation are just some introduction to the team and the history of the platform. Then we'll go through architecture and requirements that have been driving the development of the platform, and then most of the presentation will be about the features of VocBench. This is just a slide about introducing my university and where is my research lab. Actually, we are a group that was born into the field of natural language processing. I'm the kind of black sheep that at a certain time diverged and started to work on knowledge representation, knowledge engineering, and platforms for knowledge engineering. It's a distributed campus that is in the southeast of Rome. There are most of the faculties that are in all university, but differently from the other universities in Rome, they are very much distributed over a very large area in the countryside of Rome. This is the VocBench 3 team. Actually, it's a little bigger, but these are the four core people that are working on its development. VocBench is developed by a contract with the European Commission by this team, which is subcontracted by Inference, which is one of the providers of the European Commission. This is not obviously an exhaustive list of users. This is the user that initially immediately jumped into the project, or that at the start contributed in a stakeholder meeting that was held in 2016, to its development. The project is mainly managed by the EU Law and Publications Office. So a few words about its history. VocBench actually was born as a project within the Food and Agriculture Organization of the United Nations, within the European project NEON. NEON was a project, the name stands for Networked Ontology. It was a platform that was thought for managing ontologies in a modular way. And also I think collaboration was part of the features. But the FAO had some specific requirements that were not met by this platform. So they decided to create a sort of neon light within the project that was focused on thesauri. Initially they worked on something that was tightly developed around AgriVoc. AgriVoc was a big vocabulary, multilingual vocabulary about agriculture that now is available in more than 30 languages. That they wanted to collaboratively develop. They also had a very straight workflow that leads from introducing new terms, validating them, accepting them, and finally publishing them, and maybe even retiring them if they are no more we wanted within the vocabulary. Very soon the project attracted the interest of many other, let's say, development groups within FAO and also of many other organizations. So at the time I was working also in FAO as a consultant, and they asked if there were the possibility to improve that system. I say that, okay, that was really too much tightly coupled to AgriVoc, but we could try something. At the time, we were developing another platform in my university that was called Semantic Turkey. And we said, okay, if you really want to go ahead, we might try to create this Frankenstein. We make something that is created with the front end of VocBench, part of its collaboration environment. So it's not just only a front end part, but just strip the very core of its data management system and replace it with the one of Semantic Turkey, our RDF management platform. That's how VocBench was born, and it was for the first time fully compliant RDF, natively using RDF platform for thesaurus management. But again, the more you hit, the more you get hungry, as they say, and other organizations asked for many more features and many capabilities. I said, okay, this Frankenstein has been a good thing. We have gone so far until now, but we need to do things really from scratch and in a proper way if we want to do where you aim to go. And that's how VocBench 3 was born. It has been funded by ISA Square project. It has been completely rewritten from scratch, actually starting from our platform, Semantic Turkey, and reinventing the user interface and also rewriting everything about the collaboration environment. Now VocBench is, let's say, in a full health, and it's continuously developed. It's now in its fourth or fifth year of development, and it's widely used by hundreds of organizations all over the world. It has many important users, such as the United Nations, again, FIU mentioned, the European Commission itself, and there are also users in Asia and in North America, South America, well, practically all over the world. So a few words about VocBench 3 now, and more specifically into the details. These are a few requirements that we laid down, and those are the requirements that drove its development. By first, multilingualism. We are in Europe. Each country speaks a different language, more or less, and multilingualism is a must. Controlled collaboration. That means that it's fine to have many users that might work on the same piece of work all over the world. For example, FIU is an example. No, they did that original Agrovoc thesaurus that they are developing. It's available in more than 30 languages. They are continuously adding new languages, and the languages are not restricted to European ones. There are many contributors from Asia as well, and it's important to be able somehow to also avoid that the development somehow diverges. No, it's important to have contributions from all over the world, but you also need to be sure that all of these things do not scramble, do not mess things up, but actually remain into the boundaries of a very much controlled resource, and what we could say an authority resource. Now, so it's important to have collaboration, but also to be able to control it. So we revamped the collaboration mechanism and integrated it into the original application, while originally it was in the version from FIU. Data interoperability and consistency. This is a semantic web tool. Standards are important, and we make sure that all the standards are everywhere used along the system, and it is possible also to integrate with other platforms. Software interoperability and extensibility that is connected to the previous one, but at the level of software and not just of the data. Data scalability, being able to deal with very large data sets. You know, the first ontology development tools usually were just loading ontologies in memory and being able to manage a few megabytes or a few tens of megabytes. But now we need to deal, or not just, ontologies usually are relatively small because they just provide the schema, no, for developing something. But if we think about data sets that are modeled according to ontology, they can be huge. Think about DBpedia, for example, or Thesauri. Thesauri usually are large. Agrovoc is kind of 1 gigabyte, and for example, lexicons are even bigger. Think about WordNet, and so there are many requirements for data scalability in real use cases. Under the hood data access modification, the possibility to have something that can be used by users very easily, so that is user-friendly. But at the same time, you want some geek being able to go under the hood, check what's wrong if something doesn't work as you expect. So being able to make queries over your data, being able to check every single detail through the user interface. So adaptive context and ease of use. I said user-friendly for end users, but also some, let's say, RDF geek, experts in RDF need to be able to pull things under the hood. So the idea is that it needs to be adaptive depending on the kind of user and provide different user interface for that. Support for any kind of language in the RDF family. As Bismarck had introduced, there is RDF, there are ontologies on the opposite side, but in the middle, there are founding vocabularies, let's say vocabularies that are used to model the very core of the very fundamentals of any data model. So OWL is used for ontology, and you have seen much about it in the previous presentation. And then there are also other languages like SCOS for Thesaurai and SCOS Excel is an extension still for Thesaurai, Ontolex for lexicons, and then IDOAL for alignments, and so on. And VocBench supports all of them. When I say support, the thing is, if you have an RDF editor, you are editing triples. Now you're familiar with triples, you have seen it in the previous presentation. But the point is, editing something triple by triple is not convenient. There are some language constructs. For example, in OWL, you have seen that there is the possibility to model logical expressions, and logical expressions are very complex to model in triples. If you go editing them triple by first, it's very hard to do that. By second, it's even hard to read them because they are the construction of some triples that are built together and form a logical axiom that probably for you is much easier to read if you read it with some logical language, so such as description logics or some specific syntaxes that are being developed specifically for those kind of logics used within the semantic web. So the idea is, when we mean support, it's that you have specific interface that interprets the content of that is loaded within VocBench according to the models that are the core models that have been used, and then provide specific interfaces for interpreting them. Maintainability, architecture, and code scalability. We have talked about data scalability, but it's important also to have scalability of the software. That means that if you want to go ahead, if you want to add new functionalities, you are not scrambling everything up because you need to put a new patch in the system. You want the system to be already ready for hosting new possibilities. And full editing capability, RDF observability and reachability. That is, it is true that we provide simplified interfaces depending on the kind of model that is provided and depending on the kind of user that is reading them. But in any case, for the user that is willing to check any single detail, how it works, which are the nature, which is the nature of the single entities that are being used, etc. The details need not to be hidden. So the point again is the interface can look very simple, but allows through any entry points within them to check any single detail. Nothing is hidden. Provenance. The provenance is an important aspect within the semantic web. That is, being able to tell not only to see the melting pot of data that you assemble into a data set, but also to tell which data, where does it come from. So the provenance is addressed by always using metadata to address the provenance of every single element. Also, there are some features you will see later that allow, for example, for keeping an history of the evolutions of a data sets, or checking contributions, then allowing some validators to examine them and validate them and publish them. So all these things are addressed with provenance. That is, every single addition to the system is recorded together with metadata telling who did an action, which action was it, what were the triples that they wanted to add, what are the triples that have been effectively added. Versioning support, the possibility to make a snapshot of a repository and also to do a sort of time travel across different versions that you can check what's happening within a system, within a data set. Metadata descriptors. This is another fundamental aspect of semantic web and is overlooked by many RDF editing systems. The support for RDF metadata vocabularies. There are vocabularies that actually describe not just some content, but describe the dataset as a whole. For example, telling where a dataset is being hosted, where a dataset is being published, where a dataset, when a dataset has been published, who published it, and also statistical information about it. For example, statistical and quality information about it, such as which kind of dataset is this? Is it an ontology? Is it a lexicon? Is it a thesaurus? A link set? Whatever. And how many triples are in it? Is it a big one, or I can just download as a dump with a dump of a file very easily? Is it available in many languages? How much a language is represented? So statistical information, quantitative information. Customizable UI, the possibility for the user to customize UI. Okay, VocBench is not obviously an end user application for some specific domain. VocBench is a general purpose editor. But with VocBench, you can customize the user interface to meet the requirements of a specific domain. For example, I don't know, I'm using the FOF ontology. I want to model things about a people. And I want to have a specific user interface where instead of dragging properties one by one, telling, okay, I'm Armando Stellato, this is the name Armando, this is the family name Stellato, this is when he's born on 4/11/1975, but then it's very slow. So maybe you want to have a specific form that allows you to prompt all this specific information, like you would do in a specific platform that has been built for that. So you can do these things within VocBench. So it's also very convenient for data entry. And also, most important, everything is RDF. For example, in the past version of VocBench 1 and 2, the ones that were first developed in FAO and then also with our collaboration in the case of 2, many things were inherited from the past application that was using a database to store some of the information about users or about the history of the datasets, etc. Now with VocBench 3, we decided that everything has to be stored in RDF. So any sort of metadata, even application metadata, is stored as RDF information. Every user has a URI which identifies them, and every operation in VocBench that is stored in the history is stored in RDF, and there is a vocabulary for that, etc. Something about the technological stack. The presentation layer is written in Angular, which is a popular user interface framework developed by Google. Then we have Semantic Turkey, that was the original system that we developed in my university, that contains all the business logic, including collaboration. Some founding technologies that are being used is Spring, Aspect-J for Aspect programming, and OSGI for plugging extensions. Then there are connections to specific triple store and some optimizations for some triple store. For example, we enable the possibility to use GraphDB, which is a very powerful and efficient triple store. GraphDB has some improvements in terms of an index for free text search. So we developed a specific implementation of the search for GraphDB, and this is just an example. So the idea is that in some cases there are switches, that open switches, where you can also publish a new switch for a new technology dynamically within the system, and these switches take the best implementations depending on the connected triple store. The general framework for managing RDF is RDF4J. It's a very popular framework for the management of RDF data in Java. And then obviously there is the connection to the specific triple store. I will not go into the details of the architecture now, but anyway, just to see that we have a typical three-tier application that is the user interface, the one that is written in Angular, and this is served by a specific application server, even though we have a package where everything is hosted all together. Then you have the service layer and the business logic, and finally you have the specific data layer. It's important to see that you see on the right, you have extension layers for everything. That is, everything that is in VocBench can be extended, for example, connection to new triple store, new services, new functionalities, and so on, and can be plugged into the system. So if I know you is a developer here. You're very much welcome to develop extensions for VocBench for your own needs. It is mainly available as a standalone web application, but there is also Docker distributions. The instructions can be found here, and in any case, everything is here on the main site, vocbench.unimachu.it. So now we go into the features. Like I said, the technology for the user interface is mainly Angular and Bootstrap for the graphical parts. It's important here that we have a sort of, now here it's very small, but obviously you can zoom into the platform, and also here I put together like 2 screens that normally you would scroll into a single view. The idea is that you have this kind of details of any resource that you open. The interesting part is that this is homogeneous. It's the same one that you meet for any kind of resource, but the interface will change adaptively depending on the kind of resource that is examining the same query that extracts its information. So Thesaurus, which is mainly a hierarchy of concepts, will have things such as top concepts, the scheme to which a concept belongs, and then there are the labels, the alternative labels, which are alternative ways to say in the same language something like homonyms, or not homonyms, sorry. And then you have other related concepts and many other properties, practically everything that you can put about the resource. But we could say that there are these sections at the start that there are sort of elective sections. That is, for example, the top concept, schemes, and borders is a section that pertains specifically to concepts in a thesaurus. Maybe classes in an ontology would have different elective properties, such as the navigation of super classes, which use a different property. It's not the broader of thesaurus, or for example, the possibility to see logical axioms within their description. So these are the requirements. When you see this kind of scrolls, these are the requirements that have been fulfilled by the functionalities that I'm showing you. So this is how the full UI of the platform appears. Some of these, like in the advertisement, some of these pictures might look older than actually it's provided now by the system, because I kept some slides from past presentations. Anyway, most of the UI appears this way. So you have a section with which is showing the global view over the data set. In the case, for example, of a thesaurus, you have this concept tree that allows you to explore the hierarchy of the concepts. On the right, you have the explosion of the details, the one that you have seen also in the previous slide, about the concept. So you see here, I click on administrative law, I see here the description, it says that its type is cost concept, indeed. So then it says that this is the top concept of these 2 schemes, and it belongs indeed to these 2 schemes. These are the lexicalizations, and as you can see, you can scroll the content. Here you have the name of the project that's been shown, and here you have general functionalities for global data management. That is like dumping the entire data set, or exporting it, or filtering some of its content before exporting, and so on. And then there are a few basic buttons here, like the one for seeing all the projects. This one is available only to administrators. Normal users will only see a list of projects and can click only on those that they belong to. Then there is the data view, that is the one that you're seeing now. Sparkle is a query language for RDF, and you have a convenient editor for Sparkle. And here there are a series like of tools within the tool. There are specific applications that allow to perform specific functionalities over the data. It's important, like I say, multilingualism. So multilingual editing, you have the possibility to edit labels in different languages. It's important to remark that there are different standards also for editing the lexicalization aspects of RDF, depending on the model that you're using. There is a model, for example, simply for OUD, which is just given by RDF's comment, or RDF's comment, label, that is just a property for representing multilingual descriptions, but it doesn't go that much into the details of terminologies. In Thesauri, where the terminological aspect is more important, you have this distinction between, for example, pref label, alternative labels, and hidden labels. Pref labels are like the label that is supposed to be the one always used for addressing a specific concept within a certain domain. An alternative label, as the name suggests, is just an alternative possibility. So you know that if you meet this word, it means the same thing. But normally, when you have to choose which word to use, you would use the one that is connected through the preferred label. And then there are hidden labels that might represent, for example, misspells of a word. If a word is commonly misspelled somehow, you might want to keep track of this information. It's called hidden because the system will then, a system that exploits this thesaurus, will exploit this information, and, for example, will match a misspell with the proper concept, but also will never show it because obviously it's a misspell, so it needs to be hidden. So it's just, in an end user, it will be exploited. In an end user system, it will be exploited, but will not be shown. Then multilingualism also for visualization, because you can decide, as much as you can edit its multilingual content, you can decide which language are adopted for showing the concepts. Here, the name of the concept actually is a URI, http eurovoc.europa.eu/55. This is the real name of the concept. It's a code, it's an ID. But obviously, if you see everything like an ID, nothing will be understandable. So here you can choose which are the languages that will be used. For example, I chose here English and Italian. And they are properly shown both in the tree and also in the links to other resources. For example, here it's saying that this 55 is connected to a certain scheme. I don't know the code, I should click on it and inspect it. But this scheme is shown to me with the name Eurovoc, which is in the end the information that I want to see. And then you can also adjust many language preferences through a dedicated panel where you can choose, for example, the languages for rendering, the languages which are filtered to the user when they want to edit something, etc. You can decide to show flags or to show the language codes. Many people are very strict about this because actually the flags do not really represent the language. I mean, for example, for English, we arranged this by putting the American and English flags, which in any case is not something complete because there is also Australia, for example. And then we use the English flag for English British, the UK flag for British English, and this one is reversed. We have fixed this, and the American flag for the US flag for American English. So in any case, this will never be a complete representation of that. You use English in India as well, no? So the thing is, if you want to be stricter about that, you can just decide not to show the flags and show the language codes here. Another part is that the UI itself is multilingual. The newer version of VocBench that will be released in the next month offers also a multilingual interface. You just select the new language from here, for example, and then all the user interface will change according to the chosen languages. For now, there would be only Italian because it's the one that we have used while we were developing VocBench. But the thing is, we will distribute to the community the translation files, and then I expect many more languages to come soon. Custom forms is the thing that I mentioned before. It's a way to allow the user to create some forms for data entry that are exactly modeled according to their needs. There is a language for representing these forms. It's called Perl, and actually it's a language that was born for, in general, triplifying any sort of unstructured content. What does it mean? That, for example, you extract some information from text because you have some text analyzer, and then you can transform this information into RDF. We used an unorthodox, let's say, interpretation of this language by interpreting the data that is extracted from anything, any sort of unstructured information, actually as the data that has to be asked to the user. So it's still to be provided. But with the same interpretation, then we are able to transform the data that is provided by the user into some RDF data arranged into the graph. And so all these things later becomes a user interface. For example, here you have some custom forms for the very complex patterns that are used in Ontolex Lemon, which is a standard for representing lexicons and complex syntactic, morphological, lexicosemantic features. So here you have some patterns. Now you can choose the pattern that is the proper form. And then you may see directly a form that is populated with many widgets where you can enter directly all the information instead of adding one by one later. And this is how it appears once the data has been edited within. This is just an excerpt from the concept details that you have seen before. Role-based access control. This is an important feature as well. It's about the possibility for different users to have different authorizations to do things. This thing is usually called in literature role-based access control. That is, you have the control of the access depending on the role that is associated to a given user. Let's say that talking about Rdf, one could be just a terminologist. That is one that is able to edit Zaurai, but maybe has no strong knowledge on how to engineer information. So maybe it shouldn't be granted, they shouldn't be granted access to ontologies or to edit ontologies. Or one can be a lexicographer, somebody who is proficient in a certain language and should be allowed to edit the content in some language, but not the semantic part, because they are not knowledge engineers. No? So this thing is usually called role-based access control because of the roles, but actually what we did is something much more fine-grained. Our system is not really based on role, it's based on capabilities. That is, in our system, we specifically define every single capability that can be used for every single specific actions that you can perform within the system. So a role for us is actually not just something that is associated to a certain action. In traditional role-based access control, the implementation of a system is like that. You want to, I don't know, add a concept. Okay, you need to be at least a terminologist on a Rdf geek, etc. So binding the roles to the actions. In our system, the actions are expressed with a specific language that is defining the capabilities. And then the roles are simply collections of these capabilities. This way, you are free to create new roles with the capabilities that you want to associate to that specific class of users. So you can create practically new roles, a new class of users, when you can very much tailor the information, the capabilities that you want those class of users to have. There is a language that we created for specifying these capabilities, and it's based on a concept where you have a topic, then which is described by an area, by a subject, and a scope. There are like three different levels of detail in some topic. For example, the area might be Rdf, that is everything that is about the editing of the content. And then you have the subject and the scope. The lexicalization here is a sort of shortcut for telling everything about lexicalization. But you can go much into the details, telling that, for example, somebody is able to edit SCOS-Excel labels, which are a kind of label in a specific language that is COS, the one for Thesauri, but not, for example, lexical entries in a lexicon. Or in this way, this sort of shortcut say, okay, whatever the model, you are able to edit the lexicalizations present there. And then there are other entries such as the project management, user management, custom forms, system administration, and RBAC, which is a role-based access control. That is this same editing. And then you have the classical things like create, read, update, and delete, not the crude acronym for the various operations where you can apply them. No? For example, the lexicalization, you can create and you can read them. Validation has been added to the classical crude acronym, and it's the possibility to validate actions, and that is when validation is enabled into a project, somebody performs some action, and you are the one, if validate is enabled, you are the one that can validate this same action. Now, the extensibility of VocBench. In VocBench, you can, there are three, you can write extensions for its functionalities. There are mainly three areas. One is sale extensions. These are low-level data management extensions. Service extensions, that is add new functionalities to the system that can be invoked through a service. And extension points, that is functionalities which are already defined in VocBench. These are not new functionalities, but the way that these are implemented can change, can vary. So the idea of the extension point is that you have a point in which you can add a new implementation of an already existing functionalities. Just to give an example, there is an extension point for collaboration. You can connect VocBench to collaboration platform. Probably many of you know Jira, which is a very popular collaboration platform for projects, usually software projects, but indeed it can be used in any sort of project. No? And you can connect to Jira, and for instance, you can connect issues in Jira, tickets. No, yeah, think also of ticketing, ticketing platforms, this sort of things. You can connect a ticket in Jira, an issue, it's called in Jira, to a specific resource in VocBench, so that, for example, the discussion about how this concept should be edited might be carried on in Jira. And then finally, when you reach an agreement, you can apply the changes in VocBench. In many cases, things can be done without a collaboration system because VocBench itself is a collaborative environment. So for example, you can add a resource, you can add also an editorial comment on the resource, and then somebody can check your operation and can validate it. But if a more thorough discussion needs to be carried on, usually people, what do? They may carry things along in emails, or they may have a chat, but then these things are lost. So a collaboration environment is exactly what you need for. Now you can connect these issues directly to a resource. From VocBench, you can directly access that resource. And then things is much smoother, no, in this sense. Why it's an extension point? Because we define everything so that different collaboration systems can be connected. The one for Jira is not an hardwired functionality, but it's just an implementation of the extension point. For instance, for the new version of VocBench, we are adding a new collaboration system like FreightCamp. And if you have, for example, your own collaboration system might be developed by your own company, you can write a connection system for your collaboration system, and then it will be automatically displayed within VocBench. So, okay, the cell extensions that are available now in VocBench, these are the ones that are deployed within the triple store that you use to maintain the data. They need to be there because they need to be closer to the data and not closer to VocBench. VocBench interacts with them. There are two. One is for history and validation. One is the trivial inference system. A few words about history and validation because they are very important in VocBench. When validation is enabled, whenever you add something, it's shown in green, italic. This means that this is a suggested added content. Somebody suggested to add that, but it has still to be validated. And then you have personale non statuario here, statutario, sorry. This is a label that was available for this concept. But somebody that was analyzing the concept was saying, no, this is not really correct. This should belong to another concept. They confuse two different aspects in the same concept. So somebody suggests to remove it, and this is stroke and it's in red. And so what happens is that you get these. I mean, it's very easy for the user from the perspective of the user, but it's very complex. We wrote a dedicated paper on this about change tracking in Rdf data, and we performed also a survey of different approaches to the problem, and then also we gave our solution, our approach, and we implemented that in VocBench. So this is the validation screen. Here you can see the actions. It's nice to see that the actions actually are quite understandable because you see here the action is within the SCOS Excel model, and it's add alt label, add alternative label. And these are the parameters for the action that are being carried on. An important aspect about scalability of the system is exactly lying in this point. In the previous VocBench from FIO, whenever you wanted to add a new action, the new service, for example. You needed to take this into account also for the validation part, because you needed to write the correspective of the related version of a validable action inside the versioning, the validation system. In VocBench, actually, every new service that is provided within the system is decorated with some annotations in the code that automatically allow it to be published within this interface. So nobody needs to take into account new changes and bring them into the validation and reflect them also in other parts of the system, because everything is performed automatically. This allows for continuous, seamless evolution of the system without caring of the various intricate connections between various aspects of the system. And then also you can click on the left. This is the code of the commit. That is exactly the triples that have been added. Obviously, you might see this information with different eyes. Somebody who is just in charge of checking the terminology might say, okay, what is the concept that has been added? This one. You can even click on it and inspect it. And then what is the new label contrattisti? I think it's fine. Okay, I accept it. Or somebody might go checking into the exact triples that have been added because they want to be sure about some details. So both things are fine for satisfying the needs of different users. For example, here you can check that these 4 triples have been added because they are represented in green. There is a term blacklist because there is also the possibility to decide that if somebody rejected the term that was proposed by somebody in the past, then that rejection has been performed, has been decorated with some motivation, telling, for instance, oh yeah, I rejected this term because it was not proper for this concept, because there is already another concept that is good for that. So a new user that prompts the same term will find, before being able to add the term, will find that a rejection has already been performed. We'll see the rationale for the rejection, and then might choose to go ahead in any case, because maybe things have changed and they decide, the user decide that in that case the addition is proper, or they might indeed reflect on what has been written in the past and not add the term again, so avoiding to repeat the same mistakes again and again. Then there are some trivial inference. Bismarck may have talked about reasoning in OWL. This is the possibility to express axioms that allow for inference. For example, telling, I don't know, all people who are 100% Chinese have black hair. So in that case, you might create some inference telling, okay, this person is at least from an ethnic point of view, not obviously from a nationality point of view, is Chinese, so he has black hair, or probably is the same for India, I guess. Again, it's an ethnic point. Sorry, so maybe it's not the best example, but anyway, you understand the thing, no? And this trivial inference will perform this thing automatically when you edit the content. So why it's called trivial inference? Because there are reasoning is not something simple. There are also, I mean, different kind of reasoners, because depending on the complexity of the modeling system, it might be easier or more complicated, or probably not being reachable in a finite time to tell if a given expression might belong to the implications of a certain set of rules, set of axioms in a system. So the point is, these things are complex. They usually require other separated systems, and these systems work seamlessly together with your while you edit the platform, or usually are run after you edit it, to expand, materialize new triples which represent the inferred knowledge. However, when people edit, sometimes they don't want these complex derivations to be inferred. They say, okay, we will compute them later when we publish the system, but at least I would like to see simple things. For example, if I say that a property is an inverse of one another, for example, I have a property father that tells who is the father of a certain person. an implication, an inverted implication of father is that that father will have a property that is son, or at least child, that will tell who is the person to which he gave birth. So the point is, at least this kind of inversions, you would like to see them immediately and not having to realize them later. Because if I want to move from the resource describing me to the resource describing my father, I would like to see that there is that connection immediately. So this trivial inference just stops about very trivial inference aspects, but that the user usually want to see immediately when they are editing the system and not later, because they might miss something if they are not computed. And also this information is directly written within the explicit data that you create. It's not added to the, let's say, added materialized content. It's very convenient in many cases, and people would decide to switch on this feature. And then service extensions. Okay, I will not detail these parts. Maybe for developers it might be interesting, but just to see that we developed a very elaborated vocabulary for describing concepts that saves a lot of code. For example, here, this is all business code that does very boring and repetitive things, such as retrieving a series of resources which are needed to assert the information, and then assert the information, prepare a set of transformations for getting some content. Here you do everything with this. You see, this is just the declaration of a method. And then you have these ones are annotations. There is still no code written, because everything that is written here is represented through these annotations in a very expressive way. Then obviously the service will do something, so there will be the implementation, but the implementation can focus exactly on what the service does do. While this information is the descriptive one that carries on all these annoying things. In this case, for example, this one is telling that this is a service operation, so it will be automatically published as a service. It's a read operation. So for instance, if the code maliciously tries to write something while declaring it to be a read, it will not work. The read here will make so that within the code, the retrieved access to the data will be read-only. Pre-authorized here, it's a tag for describing the kind of access that is the kind of authorization that is necessary in order to perform this action. As you see, we are using that language that I described before for the authorization. This is a capability. Do you remember the area? This is the topic. The area is RDF. In particular, the subject is concept, so being able to do something with concept. And the scope is taxonomy. So this is about the taxonomy of concepts within RDF editing or reading. And here the capability is just read. So you don't need to be somebody able to edit a hierarchy, but it suffices to be somebody able to read the hierarchy of concepts. And then there is the description of the service. Also, you see here there are a lot of annotations, for example, telling it's optional to provide the scheme to which a certain concept belongs. But if it is provided, it needs to be within the resources. Otherwise, an error will be reported, and so on. Extension points I already talked about them. There are many extension points. I made the example with the collaboration backend, so for Jira, and another one coming from FreeCamp. But there are many others for import and export of data, for transforming RDF data, for rendering the data, the search strategies that I already mentioned before, URI generator. When you create URIs, maybe your company or your organization has some specific requirements about how concepts are being shown, so or being created, the ID. No? So all these things can be configured. There are many more things, but I want to stop here. And there are, let's say, I started at noon 10. Bismarck, can I carry on for 10 more minutes?
Not 10 minutes, maybe, yes, 5 minutes. Oh,
yeah.
Anyway, we have the lunch break after this, following this, your talk. So I think, yes, we can proceed. Let us proceed. Yeah.
Okay. I will be very quick. I wanted just to show here. Sorry, I will zoom a little. Do you see the platform?
Yeah.
Okay. So you see, for example, here I'm on a thesaurus. I want to show some features of VocBench which are also very interesting. VocBench, oh wait, it's is it showing again the
No,
screen?
see you only, sir. We see you only, sir. We don't see the VocBench
Okay.
platform.
I will schermo due. Okay. So now you see it, right?
Yes, sir. We are now able to see.
Okay. So this is the screen of the system. I want to show something that is not about editing, but it is about exploitation of metadata. This is very important. This is something that should be at the core of the semantic web. And VocBench is trying to foster the creation of metadata, because, you know, it's an important aspect of the semantic web, but it's been not really cared too much until now. We see now that there is an explosion of these metadata descriptors, but still they are only a fraction of all the data that is actually published in the linked open data clouds. That is that part of the web that is related about the linked data. So this is a thesaurus. It's a thesaurus about environmental science. Now, let's say I go on agriculture. The concept describes agriculture. Sorry, I loaded it just now, so it was loading still information. And here you see that there is XMatch. XMatch is a property for linking to other thesaurus. This is what creates the semantic web. The fact that every dataset that is being published somewhere might be linked to other datasets. It's like a link in pages. In the web pages, you have links that connect to other pages. And what the indexing system like Google do is that they travel around these, they trespass, these, not trespass, sorry, traverse these links in order to link and also index all the web. So for datasets, it's the same. You have links that connect them. Also, this enables to have semantic links, semantic connections. You know that if the concept of agriculture here, which is identified for a machine, I mean, for a human, these are the labels, but for a machine, this is concept the www.eonet-europa.eu gamut concept 232. This is the ID. But since this has been connected to these with this alignment property to aims, fau, org, AES, blah, 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 we know that this concept is about probably agriculture in AgroVoc, and the system knows that as well. So, for example, you can make also queries which go from dataset to dataset by using the interpretation of the dataset you know to make a query on a dataset you don't know. And this can be carried on automatically by the machine. VocBench, in this case, you see that this one has been, this concept has been rendered. And you see agricultural policy, politica agricola in Spanish, and politica agricola in Italian. So if I deactivate the rendering of concept, you see that this one actually is represented with its code. But why this one is represented with its code? This belongs to another thesaurus. You see that there is a different namespace, which is EuroVoc. While this one, but it's recognized to be a concept, and when I activate the rendering, it's rendered, even though it's not here. This is because if I go here, there is a metadata registry telling that for this namespace, EuroVoc, there is a known dataset, one that is on the web, and there are coordinates here for reaching out on the web, and one that is hosted in this same very platform. And then if I look in the list of concepts, indeed, this is the version that was linked, and this project is open. It means that from the project we were in, VocBench knew that there was another project containing the data for this. So he made a separated query, retrieving the information for this one and showing it in a convenient way. Now, if we click instead on this AgroVoc, I've been able to retrieve the information, even though here this was disconnected. The word icon means that this is somewhere on the web. How do I retrieve this information? I retrieved it because, as you see, I guess you can see that. If I click here on the status symbol of this concept, it says that I have accessed it on the web. It's a remote dataset. It's available here on this link. And I accessed it by making a Sparkle query on the web. This is, again, because I knew it from the metadata registry that there is an instance of these datasets, AgroVoc. This is the Sparkle endpoint. That is the place from which you can make Sparkle queries over the web. It's not available here at all, no? And this is all the information about it. So if I go back to here, this information, you see it's in yellow. It means that it's read-only. It has been retrieved from the web. It's not available within VocBench, but a query has been performed over this concept. The information has been retrieved, and it has been shown exactly within the description of VocBench. If I copy this, sorry, since I had to enlarge the screen, this is the description as it appears on the web. And this is that same concept that has been retrieved within VocBench. Obviously, VocBench will not access this web page. VocBench will make a specific query to the dataset and retrieve the information in RDF and rearrange it into something that can be shown seamlessly in the same kind of user interface that you use for local concepts. Now, if we go here on project and we enable, because there is also a view for AgroVoc here, let me check it. AgroVoc. And we enabled it. Sorry, no, it was Eurovoc, the one missing the description. So, no, it was AgroVoc, sorry. If I look, I'm still in the, no, let me go back to the Gamut project. Now I look again for agriculture. And if we go again to the links, you will see that also in this case, AgroVoc has been recognized to be a concept. I didn't perform, sorry, the analysis of the data set to tell which is the lexicalization available for it. So it only shows this URI. But as you can see previously, before there was the word icon, and now there is the concept icon, because now it knows that there is a concept, there is a project within this same platform that is being open and is corresponding to that one. So it went to this concept and it opened it and it recognized that this is indeed a SCOS concept. So it adopted the proper icon for it. Ah, sorry, now I forgot to enable the rendering. And if I enable the rendering, both of them, before it was only the one from Eurovoc. Now even this one from AgroVoc is being rendered because there is a local version that has been loaded within VocBench. So the metadata registry goes in between and seamlessly between local data and data that is on the web and takes the best that he has. If there is something local and it's reachable also, because we also care about privacy and security issues. So each concept, each project must grant access to its own content to other projects in order to perform this kind of alignments or even to inspect the content. So, okay, there are a lot of things to check into the details and to discuss here, but this is just to give you an idea that in this case, things such as metadata can be exploited by the same systems in order to serve at best the content for users. I think that that's all. And we can go along with questions if you have any. And these are some of the contacts for VocBench. There is the main site. There is a mailing list. I invite all of you, at least those interested, in subscribing to at least to the user mailing list here. Then there is a developer for those who are interested to contributing to, for example, new extensions to the VocBench project. Semantic Techniques is a mailing list specifically for the backend of VocBench. That is the service platform that is behind that. It's important to say that this platform can be used to power also other applications than VocBench. Okay, so if you have any questions, I'm here.